While looking at the sky at night, we perceive to be under a dome made of stars, so we are just under a giant cupola we see above us. Now we try to see with the stellarium.org application how is this visible in a computer. How can we see the sky through with the help of an application? If you were lucky and living in a very dark region, we would see the Milky Way above us. And with the help of this stellarium.org, we can let the sky rotate. As you can see, stars rise and set just as the sun does. Now the moon appears here on the top. Now a grid appears in the sky, and this grid corresponds to red ascension and declination. All the stars have coordinates with respect to this grid. As you can see, most of these lines cross in one point which would correspond to the Polaris. Polaris is not rising, neither setting, it's always there, and it's very easy to find it by following the last two stars in the Big Dipper and go straight ahead for around 30 degrees. This way you will have the reference for the north. Now we can, with the help of a stellarium, accelerate the rotation of the sky and see clearly how all the stars are rotating around the center, which corresponds to the Polaris. Even when the sun rises and the sky becomes clear, you can clearly see that all the stars are still there, rotating around this fixed point, which is Polaris. Well, all the stars are still there. Let's find the sun. We have to look due south, and we find the sun, which is itself steady with respect to the reference frame we are using, which is right ascension and declination, as I said before. Now, with the help of preferences, we will add a line which is called ecliptic, and we will see that the sun is crossed by this line, which is called the ecliptic. Now we add it, and we see in light red in this case, and the light passes through the sun. This line is an apparent line where the sun moves throughout the year. Now we let the sky rotate again, so time goes faster and faster. Then there is this red line crossing all the other lines, including the zero declination line, which corresponds to the equator. In other words, this is the projection of Earth's equator in the sky. And these two lines are tilted by an angle. And for this reason, they have a crossing point right here. You see this point. All the information on the left tells us the coordinates for each point in the sky. What is interesting is that this point lies in the Pisces constellation. Despite this, it was called the first point of Aries, the first point of the ram, because in the past it was in the ram's constellation. We go on and we see that the moon is very close to the ecliptic line, so the red line we see there. And also we will see that all the planets are very close to this line. We make the night go on faster, And now we see planets appearing here. We see Venus and we see Mars, which are very close to each other and very close to the ecliptic plane, where all the planets move close to this ecliptic plane, which has something to do with the solar system. Now, when you look at the sky, you don't perceive a three-dimensional view, you just see bright points in the sky. So you may think that they are all on the same plane. For this reason, in past years, humans grouped those stars in constellations, inventing very nice stars depending on the cultures. Now we can use the stellarium to let the constellations appear magically in the sky. Now, wait a moment. Almost all of us know what is the zodiacal sign for each. For example, mine is Leo. But what I knew is that Leo goes from July 21st up to August 20. And now we are in September. Then why is the sun inside Leo instead of being inside Virgo as it should be if really those zodiacal signs would indicate what is the month? So why is there this difference between what we expect and what we see? So the first reason is that the crossing point between ecliptic and equator is called the first point of Aries. And why is it called first point of Aries? While it is lying in Pisces constellation. The answer is that 2,500 years ago, when Hipparchus made his observations, this point was effectively lying in Aries. So this point has moved throughout the epochs. Well, what could be the explanation to this fact? The explanation is connected with the fact that the Earth rotates, but it rotates exactly as a spinning top. For this reason, it wobbles. So if this one were the ecliptic line, the Earth was rotating like that, or falling. Okay, so as you can see, if you would see, there is a clear change in the axis. This is also related to the fact that the Polaris has changed throughout the epochs. let's use the application to see what happens if we go back in time. So let's rotate backward the time, backward and backward and backward, faster and faster. We see that polarities across the years seems to be more or less always there. So we get back to 200 years ago, 300 years ago, almost when Columbus sailed and Polaris was still there, rather close to the north. But if we get much farther in time, now we see Polaris is like 10 degrees from the center of this rotation. If we go back in time, we see that Polaris changes its position, and the north or the center of rotation is not Polaris anymore. Get back in time more and more and more and more until we reach the epoch of Aristarchus, even before Aristarchus, the early travelers across the Mediterranean Sea. You see here the Big Dipper on the right, still there, but Polaris has changed its position with respect to the center of rotation. You could see that the Big Dipper is indicating the north better than Polaris. Yes. Now we move across the years just by putting a date, just to see what happens. And what happens is that Polaris changes its position. We can get back up to 20,000 years before Christ. And again, there is a huge distance between the center of rotation and Polaris. Or we can go even farther in time and or reach the future, and we will see that in the late future, say 26,000 years from now, the Polaris will still be the same we have now. So this means there is a cycle of 26,000 years, which is a cycle of the wobbling of the Earth.